this. Go with it here. Welcome to the recap of 5.1. We are dealing with chapter 5 because it's a precursor to chapter 6. So we're learning all the different relationships of all the different trig functions here. The reason why we need it is because when we get more complex equations in chapter 6, if you're trying to actually solve it, you're going to have to simplify it, just like we used to do simplification in algebra, right? And then eventually simplify, like, okay, now I can solve this problem. So same thing happens with trig, a little bit different, but still the same as this whole concept of just trying to simplify it further and further down so we can solve them. Okay, so don't need to write all this stuff down because I'm going to go through it really quick here. Let me kind of do show one or two from last time, and then I'll jump in to do some more. Okay, so what do we need? We need all the different relationships we know so far. We need to know the reciprocal relationships, so sine, cosine, tangent. We also know the ratio identities between tangent and cotangent. Next, to spend some time on this one here, it's the Pythagorean theorem relationships. So we have three major ones: sine squared theta plus cosine squared theta equals 1. We know that from a long time ago. We have the tangent and secant relationship and all the different variations that they do. We good? Boom. So not going to be fast, not going to be slow enough to you guys copy stuff down here. So, but we'll come back to them if we need be. And then cotangent and secant relationship. There it is. So what did we do? We started off proving identities. So we did something like this. Maybe something like this would be easier. And so whole goal is, can you prove that that is that one? So the left side matches the right side. And so 99% of the time, what should we do? Good students, I taught you well. Yeah, so 99% of the time we turn everything into sines and cosines because we know how to work with them. They're easier to work with. Then we have a good handle on them. So then from there we go from there. The only time you don't is when you can clearly see this sort of relationship, like something like this right here. You have a tangent squared plus 1 sitting there, and you're like, oh, you know what? That's going to be secant squared. I can really go that fast. And so all this is going to do is going to save you some time. Cool. So on the homework, what's going to happen is you go somewhere and you're like, man, why is it not working? And then all of a sudden this little light bulb appears and you're like, oh yeah, that's right. Because I totally forgot about that identity. I could use that. That's kind of what's going to happen. Good. But you're really just trying to match one side and the other. And so the famous thing that we're going to do after we match them, we're going to put QED over here on the bottom. If you have a 1 on one side, eventually you think that everything should cancel and give you a little nice 1 over here. So that's what you're looking for. And eventually at the end, you do want to put the right side and the left side being exactly the same. QED is a Latin term, which means can't pronounce it, but that which was to be demonstrated. That's pretty much what it means. Kind of cool. We should ask the Latin teacher, see if she knows. Okay, where we left off, E right here, we left off factoring. So we went progression of just doing, let's go right quick here. We went progression of just changing into sines and cosines. We did it again. We went to factoring something out, just like algebra. We can, if there's something the same in both of them, we can factor out that piece. So factoring is in the process here. And common denominators is in the process here, right there. You can get common denominators here. And next is this whole concept of some major factoring from algebras here as well. So if you're stuck, you can go back to say, you know what, that's to the 4th power, that's to the 4th power. I wonder if I just label one as X, one as Y, how would that work in my algebra? And so you can kind of, that's a little help to sort of get you there. And eventually it works. That's so great. Okay, so next. And F is up for grabs right now. Here, just for a few more, like 2 more, we'll finish up with. Let's see if that F. Okay, so factoring, we proceed with factoring here. All right, boom, all yours to start off with first. Go for it. All right, talk to me. Anybody, what did you at least try to do? All right, not talking to me. That's fine. I'm thinking that the numerator there, 1 minus something to the 4th power, that probably could be factored down. And so again, if you're kind of stuck, then off to the side, think about how would that be factored down in algebra. So I have a 1 minus something to the 4th power, 1 minus something to the 4th power. Yeah, isn't that from algebra? Isn't that going to be 1 plus x squared, 1 minus x squared? Does that make sense there? It's a difference of 2 squares. One's always a perfect whatever. So I can do that. And then I can go some more, but at least for now I have that. So let's do this here. So that numerator now becomes 1 plus cosine squared theta, 1 minus cosine squared theta. And we have that 1 plus cosine squared theta on the bottom. You guys talk to me. Does this feel like a geometry proof? Remember our geometry days? We're not writing the reason off to the side, but you could as well just write the reason off to the side. You could say from algebra, we know this, therefore this. And then we say simplify on this side because we're going to simplify something. So it technically is a geometry proof, but it's a algebraic form. Cool, cool. All right, I think we got this here. Those two are going to cancel each other out. Got 1 minus cosine squared theta and anybody else. Perfect. Okay, yeah, it's one variation of it, right? So we go back up here. We say to ourselves, you know what? I wrote something like that down. It is this one right here. Let's see. This one. I'm going to use 1 minus cosine squared theta to become sine squared. Love it. Pretty cool stuff. And QED. What's another symbol that we can put down? The box. The box, The check. Any one of those will be fine. Box became popular in 1970s textbooks. I don't know why, because people wanted to get away from Latin in 1970s in education for a little while. And then the check was like, I'm done. Okay, so factoring. Question, you guys, do we need another one for factoring? Okay. Let's check to see which one would work nicely here. There's that one. Ooh, okay. FG. Minus this one. Let me throw this one into the mix here. And then let me find a good factor one because I didn't find a good factor. So this one right here.
Wait, so are we doing this one?
Yeah, let's go with cosecant squared theta minus cotangent squared theta is equal to 1. Go for it. This is one of those where I think you can, if you like, you can go back into sines and cosines, but also to make it faster, is there a possibility of, okay, that one I like.
So if there's already like a proof for it, do you just put 1 equals 1?
Oh, awesome. Okay, yeah. So let's go back to our little pieces here. So the book does not do this. The book only shows this top one here. We did it in class. So this little piece right here, that's your main one, right? What we did, because we're cool like that, we made these 4 different derivations of it, right? So we want to use, to make it easy as possible, you want to use as much derivations as possible because it makes it a lot easier. So you see, yep, cosecant squared theta minus cotangent squared theta, that's already a 1. That's a derivation we have from here. Even though that's not the way the textbook would present it, it would still do the previous one and it'll do some, but in this one, done right here. This would be good enough for me because we made those derivations. Thank you, Karina. That was cool. It's so interesting. Guys, real quick here. When you go through trigonometry, you go to calculus, there's 3 semesters of calculus you got to do. And after that, you're done at the top of the pyramid of computational mathematics. That's kind of like you reach the top of the pyramid. Of course, there's statistics and there's some offshoots from calculus, but essentially you're done with the formal understanding of how we have reached computationally in math. And then what happens is you do proofs. You start proving things are true. So you go back to algebra, you start proving all these laws, right? And so the question is, how much detail do you put in the proof? That's always a weird one. It's the same thing. Is how much detail do you prove in? Because you have these, you go for 5 pages if you want to sort of like prove every single thing. But what you do is you develop these little rules, right? And then you start using the rules. Almost like coding, if you got a coding language, you start making these small little functions, and once you make those functions, you can make bigger functions. Same concept.
Can we go through this one as if we didn't know what Karina brought up?
Sure.
I'm a little bit confused on how to do it.
Absolutely. So let's go back over here. Let's do the textbook method here. The textbook method says I'm only given this as the identity. So if I see a 1 plus cotangent squared theta, I can switch it to cosecant squared theta. If I see it the other way, I can plug in 1 plus cotangent squared theta. Now, if you did not think about that, then you would have went back to sines and cosines, right? And then you would have had common denominators and did all that. So let's go for it here. So I see a cotangent, I see this guy. So I'm going to change it into a 1 plus drop the parentheses. Cancel, and we are done that way as well. All right, so.
Can you just subtract the cotangent squared theta and like make it the actual proof?
Like subtract it to go to the other side?
Sorry, add it, not.
Cool, good question, good question. So you cannot move from one area to another because that would be solving an equation, and you're not solving an equation, you're proving an identity. So you're ready for chapter 6, George. Okay, we're good there. GH. Okay, I found a good. Sorry, let me go the other way. I found a good. This is a good factoring. Oh, sorry, not 2, 4. 4 is over here. 4, 4. That should have been a 4. What's up with that? I'm not erasing here. 4 right over here. So sine to the 4th a minus, cosine to the 4th a minus sine to the fourth a is equal to 1 minus 2 sine squared a. All right, let you guys take this one yourself. Go for it.
Wait, it's just sine A.
It's 1 minus 2 sine squared a.
No, on the other side.
Cosine?
Yeah.
Sine.
Oh, sine to the fourth.
Fourth. Oh, there it is. My eraser is working now. All right, all yours. Go for it. I'm thinking you probably need a factor. I'll let you guys try it. All right, I'm thinking I'm going to simplify the right side first. Is that okay? And again, back to algebra, if need be, x to the fourth minus y to the fourth. I'm kind of thinking that in my mind. Two things taken to the fourth power. And the difference would be x squared plus y squared and a x squared minus y squared from algebra. We good there? Cool. So this one's going to be a long one here. So how about cosine squared a plus sine squared a, cosine squared a minus sine squared a on this side, and this side stays the same. I don't need to write it down if I'm not going to change anything to it. So it's just more time on homework. Why do that? Cool. All right, I'm thinking that's a 1, is that right? That's a Pythagorean theorem identity. So that goes away. So now I'm left with just that right there.
Wait, wouldn't it be 1? What? Oh, wait, no.
Oh, you can write the 1 next to it if you like, right? I mean,
Yeah.
to give you more, and again, this is how much clarity do you want? I can write it like this, and then to show that step happened, and then I can show this step happen. Just don't go too many steps out because then you might just get confused. All right, next, what should we do? I see, just real quick here, I see on the right side, I see a cosine and a sine, right? On the left, I just see sine only. So I think I want to just figure out a way to get rid of cosine squared. Go ahead, anybody.
You just trade it in for 1 minus sine squared.
I'll go with that, 1 minus sine squared a. All right, get rid of the parentheses, so that's simplified. And I think I'm good. So 1 minus 2, they're both negative, 2 sine a. And then at the end, since we haven't done anything with that side, we can just bring it all the way down. There it is, and I am done. Doom, doom, doom. Okay, that's factoring techniques inside this process. All right, you guys comfy with it now? Good, Grace, or the other way? Which one?
Either way.
Either way. Okay, one more. One more type is this whole concept of multiplying by 1. Do you guys remember ever multiplying by 1 in algebra? GHI. So I have this right here. 1 plus sine of t over cosine t. Cosine t, 1 minus sine of t. Okay, you can't cross multiply, right? Because we're not solving. But we want one form to be the other form. Bummer. And notice all of them are just single units, right? It's just sine. It's not sine squared. I can't change anything, right? And then I don't have any identities. I don't have any identities that actually change sines into cosines either, right? Linear forms. That's not cool. So here's what we'll do. How about, notice on the one side, especially on top, there's a 1 minus sine t on this side, right? And there's a cosine on this side. So I'm thinking to myself, you know, in order for these guys to be correct, I eventually will have to have a 1 plus sine t on that side, correct? I'm going to have a 1 plus sine t on top of some kind of denominator. So here's what I'm going to do. I'm going to multiply by 1 plus sine t on this and 1 plus sine t over here. Question, am I allowed to do that? Yeah, because I'm multiplying by 1. I'm not changing anything. Multiplication by 1 is totally allowed.
So you can't change the side that you're proving unless you're multiplying it by 1.
You can't cross multiply. You can't multiply this side to that side, right? You can't do that. You can always multiply something by 1 because 1 keeps everything still the same. So let's see what happens here. I'm going to leave the right side exactly the same, but let's multiply the left, see what happens here. So on top, cosine, I'm going to leave those separate because there's no point of having them exactly multiplied into themselves. And look at that. On top, I do have my 1 plus sine t. Let's just see how everything works out on the bottom here. 1 times 1 is 1. And let's see, it'll be a sine t and a minus sine t, right? Hey, the difference of 2 squares, correct? So then I'm thinking minus sine squared t. All right, guide me from here, anybody?
Would 1 minus sine squared t be equal to cosine squared t?
I'll go with that. All right, then I think I have a simplification, is that right? The cosine squared t crosses off with one of those, and I like that. That's cool. I think I have that. Is that right? Yep, which matches the other side now. And there it is. There's the other little method. It's called multiplication by 1. So awesome. We got the easy ones. It's just using identities only. Got the one where you have to factor. And then you got the one that multiplication by 1 in order to make it happen. And that is.
Was just to solve the left side more, but that does make sense that you would go with the right side.
Yeah, because the complicated numerator. Perfecto. Okay. Have a good weekend.
And you want the test back?
Test back, yes, please. I will collect them on your way.